So we're going to have our equation here, and it's going to be given to us in words, and that's actually always kind of the hardest thing, mainly because there's a few steps we need to take. We have aluminum nitrate and sodium carbonate, and we have aluminum carbonate and sodium nitrate. So this thing reacts, and let me just see. This one is an aqueous solution, so I'm going to put a little AQ right here. They told us that. And the sodium carbonate is an aqueous solution. And the aluminum carbonate that it reacts with forms a precipitate. So one way I could do that is I could put a little solid here. Another thing that I've seen people do, and I haven't seen this very often, although I think your book might use it, is just they put a down arrow right there. And it basically means some solid has dropped out of there. And the last thing, sodium nitrate, is another aqueous solution, so I'm going to put an AQ right there. I'm running out of room, so my writing got sloppy. Anyway, let's perform the first step before we even get really started in trying to balance this equation. We need to convert these names into their equations. So I know that nitrate, let's start off with this thing right here. Nitrate, all right, I'm going to go all the way up here. Nitrate is a, right here, nitrate, NO3 with a -1. And let me just check my aluminum. Aluminium has a charge of +3. So nitrate was NO3 with a -1. Yep. Okay. So NO3 with a -1, and then my aluminum has a oxidation number of +3. So in essence, I need 3 of these NO3s to balance out with this one of this ALs. So I have AL and NO3, 3. All right, I'm done there. Now, let's do the sodium carbonate. Going back up to that chart, carbonate. Oh, there we go, CO3 with a -2 charge. Now the sodium itself has a +1 charge. You can see that right here, +1 charge. So C carbonate was CO3 2 negative, so CO3 2 negative. CO3 2 negative. And the sodium has a +1. So I'm going to need 2 of those sodiums to balance out with that one of these carbonates. So I have an Na2CO3, and I don't need another 2. I don't need that 2 up there because I have that 2 on the carbonate right there. And actually, I don't even need those parentheses, so I'm going to keep them there just for now. And again, this is an aqueous solution, and I'm adding these together, and that's going to yield aluminum carbonate. Let's deal with that. We know carbonate was CO3 with a 2-, and I know aluminum was a +3. We've already established that before. So using the crisscross method, or just understanding that you're going to need 2 of these aluminums to balance out with 3 of these carbonates, you'll have this Al2 CO3 3, and I'm going to signify that with a down arrow. You know, I don't really like that. I'm going to just make it with S down there for solid. And then in the end, you have sodium nitrate. So sodium is Na+, and nitrate was NO3 -1. And so those can combine nicely, just balance each other out without any kind of weirdness going on. And that was an aqueous solution. So you're thinking, man, that was a lot of work. And yes, it was a lot of work. It wasn't hard work. It was just a lot of work. But the problem is it's not balanced. We don't have a balanced thing yet. So I guess the technique I'm going to use here is I'm going to leave the hardest, most complicated looking thing for last and see if I can work that out. Essentially what I want to do, and I don't know, there's so many ways to teach this, and I think that the best way, the only way to really get good at this stuff is to make you do a whole bunch of these problems, and then after a while you get a feel for these things. I'm going to try my best to keep this coefficient to be the number 1. The reason why I'm using this, I'm starting off with this guy right here, is because he seems like it's the most complicated. Now, all of them seem like they're complicated and cluttered and all of that kind of stuff. But the thing is, there's only one aluminum here, but there's 2 aluminums in this one compound right here. And there's 3 carbonates in this one, and there's only 1 here. So let me just try to deal with this and see what I can get. All right, so I'm guessing that if there's going to be a 1 here, then that means there's a 2 here. I'm going to deal with this NO3 later. Let's deal with this carbonate. There are 3 carbonates on this one aluminum carbonate, so that means I'm going to have to multiply this thing by 3. Now, if I multiply this thing by 3 and I multiply this thing by 2 over here, then I'm going to have a problem. And my problem is, on the right hand side, I've got, let's see, 6 NAs. And as far as my NO3s go, I've got 6 of those too. Actually, this works out rather nice because there's 1 Na over here and 1 NO3, and I need to multiply those by some number so that I can make it be 6 NAs and 6 NO3s. Essentially, I just need to put a 6 out in front of there. That came out nice without having to use any kind of fraction trick or anything. All right, well, that's it.